just go through a few of these. Let's do D real quick. Do we start on the left or do you start on the right when you do these? Start on the right, yes. So we're going to start over here on the right. And your answer will be 1, 2, 3, 4 on the top. But on the bottom, you're going to go 1 map to 4, then 4 maps to 4, then 4 maps to 2. So 1 eventually maps to 2. And then 2 maps to 1, 1 maps to 2, 2 maps to 4. So this will be 2, 4. And then 3 maps to 2, 2 maps to 3, 3 maps to 1. Okay, and then if we did it right, this should end up being what? 3. 4 maps to 3, 3 maps to 1, 1 maps to 3. All right, good. How'd you do with the inverse in part C? How'd you do with those inverses? What I would do is what's inside first. So I would go 1, 2, 3, 4. 1 maps to 2, 2 maps to 4, 2 maps to 4, 4 maps to 1, 3 maps to 1, 1 maps to 3, and this would have to be 2. Now, if it's the inverse, what you do is you flip it over, 4, 1, 3, 2, 1, 2, 3, 4, and then you reorder. So we're going to reorder these. So this is going to be 1, 2, 3, 4 on the top again. 1, 2, 2, 4, 3, 3, 4, 1. And so that should be the inverse. How do you know it's the inverse? Well, if you went 1, 2, 3, 4, 4, 1, 3, 2, and you compose that with 1, 2, 3, 4, 2, 4, 3, 1, this should end up what? Should be the identity. And so the identity would be 1, 2, 2, 1, 2, 4, 4, 2, 3, 3, 3, 3, 4, 1, 1, 4. It's perfect. So this is the same as E. Any others that you had questions on? Do you want to see the proof, number 2? Should we do 2? Okay. I have it worked out, so I will be using a cheat sheet on this one. But I do like this one. Oh, rats. I'm on the wrong one. So for 3, we're going to prove that all permutations QP inverse equals P inverse Q inverse. So what they did first is they started with QP star, and then this would be P inverse Q inverse. What should that be equal to? Hmm? Well, right. It's not really even an operation. It's called the permutation process. So we do the permutation process. But I think, isn't this equal to E? Yeah. We're going to prove that it's equal to E. So to do that, P inverse Q inverse QP should be equal to E. But we're going to see if it is. Is our permutations associative? Yesterday we found out that, yes, they are. Permutation operations are associative. We didn't prove it, and it wasn't proven in the book. But what's P inverse equal to? E. So then anything times E is anything. And what's this equal to? E. You do the same thing with, I'm going to start it off and you finish it. You're going to go with P inverse Q inverse, and do that with, let's see, what are we going to do? QP? Go for it. Yeah, you probably guessed it. You just rearrange them. You're going to get the same thing. But it's not the same thing because here you were ending up with QQ inverse. Here you ended up with PP inverse. But since those are equal to each other, then since QP times, yeah, P inverse Q inverse equals P inverse Q inverse PQ equal to E, then QP and P inverse are inverses, which we knew already. And this has ran out of space here. Then, hence, they say QP inverse equals Q inverse P inverse, or P inverse Q inverse. All right, anybody want to ask a question about 4 or 4A or B? Are we good with those? Yeah, I think they're saying find out what this should be in order for this to work. So it's kind of thinking in reverse. Let's try this one. 1, 2, 3, 4, 3, 1, 2, 4. And then this is P, which is going to be 1, 2, 3, 4, and we got to figure out what that is. To end up 1, 2, 2, 1, 3, 4, 4, 3. Let's see if we can do it. This needs to be a 2. So 1, 3, 3 has to be a what? 2. Good. 2, 1, or excuse me. And then we're going to go to 2, 1. 1 needs to be a 1, I think. And then this is going to be 3, 2, 2, 4. And then it's 4, 4, 4, 3. So I think it's 1, 4, 2, 3. I want to just see if that's right. Wait, I've got it right here. Yep, looks good. And we did this one. You can check that answer in the back. Find the order of each permutation. This is going to be helpful today because you're going to be working with order. So I want to do one of these. I will do, Aiden gets to pick. P, Q, E, or S? Which one do you want me to do? Oh, you want me that one. All right. So I'm going to do this one first. So if you do this one first, 1, 2, 3, 4, 4, 3, 2, 1. Order means you do what? You operate it against what? This would be P. We're looking at P squared, right? So if we go 1, 2, 3, 4, 4, 3, 2, 1, we'll see what P squared is. Which will be 1, 2, 3, 4, 1, 4, 4, 1, 2, 3, 3, 2, 3, 2, 2, 3, 4, 1, 1, 4. What does this mean when you get E? It's an order of 2. Order equals 2 for this one. This is the first one. That would be an order of 1. If it was 1, 2, 3, 4, 1, 2, 3, 4, then that would be an order of 1. But when you operate against itself once, you get order 2. Now we're going to see what happens with Aiden's idea here. 1, 2, 3, 4. 4, 1, 2, 3. 1, 2, 4, 1, 2, 3. And I just had an idea that I kind of like. If I went 1, 4, 4, 3, does that work? Did that work? No. But can we just do another one? Let's try it. Let's see if it's an order 3. 1, 4, 4, 3, 3, 2. No, that didn't work. 1, 2, 3, 4, 4, 1, 2, 3. I just thought of this. 1, 4, 4, 3, 3, 2, 2, 1. Okay, 2, 1, 1, 4, 4, 3, 3, 2. 3, 2, 2, 1, 1, 4, 4, 3. So what order is this one going to be? That neat? Can do that. That's almost more efficient, isn't it, than doing 2 not working, 3 not working, 4 not working. You can do it a little quicker that way. Did you get all 24 of these elements? I don't know why I assigned that. I think I told you yesterday don't do it. And this is one that's interesting to try.